Okay, here we are dealing with quantitative or numerical data that we can do math with, we can find averages of, we can add together and so forth. Here we have a grade distribution that I've put in order for us. So this class got grades from 5 up to 98. The first thing we want to do is display this data somehow. And the easiest way to do that is what we call a histogram, where we break our distribution up into different groups. And the most obvious way to do that with grades would be by letter grade, right? So A's would be 90 to 100, B's 80 to 90, and so forth. But the problem with that is all of our groups would not be the same size. F would be from 0 all the way up to 60. That would be a range of 60 for F, but only 10 from 60 to 70 for D. We don't want that. We want all of our groups to be the same size. So we could use what we call a bin width of 20. So I'm going from 0 to 20, 20 to 40, and so forth, and just counting, literally just counting how many are in each group. So here's a histogram using a bin width of 20. I want you to notice a couple things here. First, it is labeled. We always label all of our graphs. And it starts at 0 on both axes. That is important. Your histograms must always start at 0. No matter what your data is, using those little broken axes is a good way to get misleading graphs. So in this class, I always want you to start at 0. So here you can see we have between 60 and 80, 10 data points. All these guys right here. Now, what would we do if we had a data point of 80? Which group would that be in? Would that be counted in the 60 to 80 or the 80 to 100? That's unclear from our picture. We could have chosen to do it either way, but we need to tell the readers which way we're doing it. So first off, if I were going to group these together, I wouldn't use a bin width of 10. Of 20, I would use 10. That way we could have all the C's together, all the B's together, and so forth. So here's another histogram, bin width of 10. Notice how I've labeled the axis here, just a number line. None of this 0 to 9, 10 to 19 stuff. Don't do that. Draw the number line out, put your marks on it. And again, we need to tell the reader where the endpoints live. I need to know whether this group right here would include 50 or would include 60. And I've decided that each group will include the left-hand point. So I've written that here. So here's a key that we're always going to include on our histograms. You don't have to do it this way. You could do the equals on the right hand side if you wanted, but if somebody got a 70 on the test, I would want them counted with the 71s and the 73s and everything else. They got a C.